Hello everyone, welcome to the first session of SAP HANA online training tutorials. In this tutorial, I'm going to explain about HANA. What is HANA? Why do we need HANA in present market? And what are the benefits that customers are going to get with SAP HANA? And how SAP HANA is going to solve the current challenges we have in the market. So before I explain about what is HANA and how HANA is different from traditional databases, let's look at what are the challenges we have in the current market. In the sense, what are the challenges we have with the existing landscapes at customers. So let's discuss about those things first. So the first challenge that customers has is the data volume, the size of the data that customers are capturing. One of the example that I'm gonna give you about how the data volume has increased right now in the market is one of the electrical company in Australia. They used to take the meter readings from every house. So just 10 years back, they used to take one meter reading for every 30 minutes, which means on a single day you are going to get 48 records from each house. The same company, now they are taking a meter readings for every minute, which means simply the number of records has grown 30 times than what they were getting 10 years back. So the first challenge you get with data volume increases, you need more storage to store the data, which means your database size has to grow. That will grow. The other thing is, once your data grows, the other challenge you get with huge data volume is getting insights from that data. You have to process that entire data set to pick the report or to do the analysis that you are expecting. So let's say with the same recordings or with the same records that they were getting 10 years back, they used to do the analysis on how much electricity has been consumed by different sectors. It can be your household sector, it can be your industries, it can be your farming sector, it can be companies. So you want to analyze how much electricity has been consumed by different sectors you have. You want to analyze the electricity consumed by time period. So by each month you want to analyze so that you get to know what is the peak season in your area, which means you can plan to accommodate the extra energy or the extra power you need in that season. So if you want to do that analysis, earlier, let's say you were processing 100 million records to get that analysis. Now you have to process 30 million records simply. So here itself straight away the growth has been too much in the data volume. And in the same way, the kind of data that customers are gathering has got a lot of dimensions now. Earlier, customers used to gather or customers used to record only the core areas data, which means like it can be your finance or it can be your sales or it can be your human resource department. Now customers want to know everything about their company, like how the people have the sentiment analysis on their company, like how people are reacting in social networks or how the people are reacting in the campaigns that customers are conducting. So they are capturing huge amount of data. So with that huge amount of data, the processing takes a lot of time, which means the processing that you are doing to perform your analytics has become expensive. So the first challenge that you have is data volume has been increased, and with this your maintenance is more. So maintenance, it can be in terms of maintaining your database, it can be in terms of the statements that you are going to run at your database to perform the same analytics that you were doing earlier. And the other thing is, customers are expecting fast response from IT department. So earlier, you get one requirement from the customer, you give them the requirement analysis, you tell them, okay, it's going to take 4 weeks, 5 weeks, 6 weeks. Then customers will wait for the 6 weeks to get or to see what they've asked, at least the first version. Now the customer's mindset has changed. So it's not like they give you the requirements, you show them what you have built after 6 weeks or 8 weeks. Now customers are expecting, they want to work along with IT. They want to see what you are building, because they don't want any surprises after 6 weeks where you misunderstand what they are expecting. So they want to work along with the IT department, and they want immediate results. They're not expecting so much of time for just one requirement. They're expecting immediate results, and that's where you have got agile methodology now instead of SAP methodology or SAP or waterfall methodology, where you gather the requirements, you build the models and then show them after specific time. Instead of that, they are expecting now agile methodology, where they can work along with IT team to build their models. So customers are expecting immediate results. And the other challenge that we have in the current landscapes or current market is, customers are expecting real-time analytics. Why customers are expecting real-time analytics is the competition has changed a lot in the market. In every sector or in any industry, you have got a lot of competitors. So you cannot simply you cannot simply stay calm, or you cannot expect that your business is going to grow over a period. So you have to be always competitive in the market, like analyzing what kind of resources you have, and then understanding what others doing, then predicting like how better you can do, and then expecting, okay, if I do something, then is it gonna be profitable for me, or is it gonna give me a losses? You have to do so much of analysis, and you have to be competitive in the market. So with this in mind, most of the times customers are expecting a real-time analytics. So real-time analytics, in a sense, whatever the current data warehousing systems we have, we always, or most of the times, we load the data from different source systems over the night to your data warehousing application, and you do all the transformations, then make the data marts ready, so that next day morning customers can come and see their reports or can come and perform their analysis. So now, if customers are looking at the data today, they are not looking at the data that has happened right now in their organization. They are looking at the data that has happened till yesterday, which means if we take the sales information, they don't have information about sales that has happened today. So they only have information till yesterday, which means they are missing some data. So sometimes that data can be vital in some of the decisions that customer may take. So in such scenarios, customers are expecting real-time analytics. So the other challenge that customers are having is they're expecting real-time analytics. And the other challenge, a few of the customers are thinking about, why should I bear so much of hardware expenses or hardware maintenance? Okay, so they want their IT system or IT infrastructure to be flexible, even when it comes to the applications that we are going to build for their analysis or for their reporting. So they want the application or the infrastructure they have to be flexible. That's where you have got now cloud in the market, and the other is like you are getting so much of mobile applications, so that they have got that flexibility with the application they have. They always don't need to sit in front of a laptop to see what's happening in their organization. On the way, they can open their mobile, they can see the data, they can check the metrics that's happening in their organization. And so they want to have IT flexibility. So it can be your mobile application that you have built, or it can be your infrastructure that you have. And the other thing is, so when we are talking about building a data warehousing, we always bring the data into stage and then do the transformations, then again do business logic, again apply the business logic, and then prepare final report data marts. So this is the standard procedure that you have with the existing data warehousings. So you are going to have so many layers before you transform your source data into proper analyzable data, which means if a customer comes with a change or a new requirement tomorrow, you have to modify all these layers. You have to modify at your stage, and then you have to change your transformations, then change the business logic, and then execute everything so that they get the additional requirements into their final report data marts. So even for a small change, you have to do a lot of changes in your system to make that available. So now customers are not expecting that. So they want those changes to be a minimum so that they can quickly get their requirements done in the system. So that also comes under IT flexibility. So these are the most of the challenges that we have in the current industry. So now, so these are the challenges we discussed. Like one is immediate results. Customers are expecting immediate results, and then massive growth of data volume. Because of the massive growth of data volume, your maintenance cost is going to be increased, which means you need a lot of workforce. Because if you're using 2-3 resources to maintain your 5 TB database, if your data size grows 30 times what you are having 10 years back, then you need 150 TB system, which means you need 10 resources to maintain that. So in the same way, when you have that maintenance cost, obviously you need more resources. And then the flexibility, they want high flexibility in their system, and they don't want complex system landscapes. So whatever we talked here, these obviously complex system landscape. They have so many layers, and you cannot change your resources frequently. You have to depend on your core resources, which means because they know the system very well, and if you lose them, you are going to face a lot of challenges with your existing system. So that is where the complex landscape comes into picture. So what are the consequences consequences that customers are getting because of these challenges. Obviously, they don't have that responsiveness now, because the queries or the reports, whatever you are running in the system, are taking a lot of time. Why? Because you have got so much of data now. And obviously, users will, or business will get frustrated because of that. Even when you are using a internet where you pays 30 or 40 bucks per month, if that doesn't open in 3 seconds, 4 seconds, you feel, okay, what the hell is going on? Why it is not opening? Why it is not so fast? Then think about the customer who has spent millions of dollars on the project and still not getting the results out. So they obviously feel that frustration. Okay. And then the other challenge with the massive data growth you're going to get is, earlier customers were always used to see the aggregated analysis. So as I explained earlier, they always want to see, okay, how much energy has been consumed over a time period, maybe by month. Now the time has come where customers are looking very deep into their data to find out some unexpected answers or unexpected things from their organization. So they are looking very deep into data, which means no more they want aggregated data. They want a detailed analysis on their data set or on their organization. So in that case, you have to push lot of data to their reports. So earlier when you aggregate the data, you might be picking only 100 records out of your 1 million records. But when you are going to have the detailed reports built, you need to push lot of data to the application layer, which means instead of pushing 100 rows, you might need to push 10k rows or 100k rows. That always takes a lot of time. Okay. Why? Because of the aggregation that we are doing right now, they don't have proper insights on their data. That is where we have got, lack of transparency. So they don't have proper transparency on their data set. And obviously, because of that, they have to guess some answers to their few questions. Okay. And the other consequence is reactive business model. So they don't have proactive business model. So where they just ask to do that change, where you get back to them saying, okay, this is done in 1 day or 2 days. They'll give you the requirement, you get back to them after 6 weeks or 8 weeks. By that time, they might have missed an opportunity where they would have grown their business. So because of that reactive model, they are losing opportunities. One of the reason why customers are spending $1 million to build their data warehouse or to build their IT is obviously to make more money. So they can look into their data, they can analyze that so that they can grow their business. Now, because of this model, if they are losing the business, then they'll again think, okay, whether do I need IT after spending so much time, so much money and time? If I'm not getting what I'm expecting, do I really need the department? So most of the times now customers are expecting their IT department to be proactive, not reactive. Why? Because they're missing opportunities. So these are the challenges that we have with the existing landscapes or existing applications we have. So most of the times with our existing landscapes, if we are talking about a data warehousing application, okay, where you bring data from different sources and then apply the business logics, apply the transformations and make the data available for reporting, and then build the reports on top of those data marts that you have created. So this is going to be the typical data warehousing application that most of the customers have right now. So if we draw a pictorial representation of what we talked now. So you have got so many different source systems. Okay, so let's keep 2 or 3. So you have got source 1, source 2 and source 3. And then you bring data into your data warehousing application. So data warehousing application in the sense, when you are bringing data, you need to have a database where you can store all that data. So you have got your database, and then when you are bringing data from different sources to your database, you need a tool using which you can load the data or you can move the data. So you need any of the ETL tool that you have in the market. So ETL stands for extract, transform and load. So any of the ETL tool you can use. Some of the major ETL tools in the market are like Informatica, you have SAP Data Services, you have SSIS from Microsoft, and so many different tools you have in the market. So you can use any of this ETL tool, and then once you have got data into your target database where you keep stage, which means it's going to be like a one-to-one map. You just dump the data you have in the source to target, and then so this is going to be your one schema. Then you move the data to next schema where you put, while moving the data from stage to transform, you are going to apply the basic transformations you need for the data sets, and then you'll create another schema. So while moving data from transform schema to report schema, you are going to apply all the business logic that customers are expecting. So whatever the data you have got in this schema is going to be the final data set that will be used to build the reports. Okay, so whenever you want to move data from one schema to other schema, you will be always using your ETL tool. Now once you have the data in your report schema, you are going to build reports. So we have different reporting tools available in the market. So you can use any of the reporting tools. So I'll just call it as a reporting suite. So you can use any of the reporting suites that are available in the market to build your reports to the customers. So you always are going to use the data from a report schema to build your reports. The major reporting suites you have in the market are like, you have business objects, and then you have Cognos from IBM, you have OBIE from Oracle, and then what else you have? You have Tableau. So there are a lot of reporting tools in the market, and any of the reporting tools set you can use based on the customer requirements and build the reports. So with the existing or with the traditional databases you have in the market, the challenge is all the databases you have in the market are disk-based database. So disk-based database is like your hard disk in the laptop, which can be used to copy your files, to move files from one folder to other folder. Now where your entire processing is going to happen in your laptop. All the processing will happen in your RAM. So this is where all your calculations or your processing operations will happen. So the disk is just used to store your data. So as a disk, you can write or read the data from that. You can copy the files or you can read the files from that. So disk will be used to write or read the data, which means the databases that we have in the market can be used to read or to write the data into it. So when you are reading or when you are writing or when you are applying some logic for that, where all those logical operations are going to happen, those are going to happen in your RAM. Okay, so it's going to be like you have your database, and you have the RAM on top of it. So this entire database will be controlled by this RAM. Whether writing data into your database or reading data, or when you have reports which needs a data set from your database along with some calculations. So what your RAM will do is it picks the data set from database to RAM. It will perform those calculations and it will push the data to your reports. So entire your database will be controlled by RAM, which means always there will be some data flow between your RAM and database. And we always know that the data flow between two layers or two applications is always expensive. Okay, so this is one of the main bottleneck we have with the current data warehousing systems. So where you need to do a lot of data movement between your database and RAM. So why we are doing this? Because of the inability that we have with the existing databases, because those are all just disk-based databases, so they cannot do any logical operations. You can use those databases to store your data. So when you want to do some operations or when you want to do some processing on the data, you have to bring the data to RAM and perform those processing or operations. So that is where the main bottleneck lies with the current data warehousing applications. So now we'll see how HANA can resolve those challenges, or how HANA can you change those challenges or overcome those challenges. And the other question that arises here is, we are talking about the databases that has built maybe 20 years, 30 years ago, when the memory cost was too expensive. Now we are in a world where you spend 20 bucks, you get 4 GB RAM, or you spend just 500 bucks, you are going to get 1 TB RAM. So we are in a world where the memory has become very cheap. In fact, the database price has become even cheaper. So now we have to think, are we using the latest technologies or the latest innovations that has occurred in the computer world in our existing databases or in our existing data warehousing applications? Definitely the answer is no. Why? Because if we look at this picture, recently we have got different processors from leading innovators like Intel, and the memory price has become cheaper, and where you can get TBs of RAMs for very less price. and you have got huge multi-core parallel processings available in your CPUs with the existing technologies. So are we really using those technologies in our current databases? Definitely the answer is no. So that is where you get HANA in picture. So HANA is a combination of both software innovation from SAP as well as hardware innovation from Intel. It's a combination of both software as well as hardware innovations from SAP as well as Intel. So from hardware perspective, they have got the multi-core processings, they have got the RAM cheaper now, and they've got the CPUs where you can put up to 512 cores, because of which you get huge parallel processing available at database level. So as I explained here, when I am getting a RAM very cheaper, instead of storing my data in a disk-based database, why can't I store my entire data in a RAM itself? When it is cheaper, why can't I store my entire database in RAM? The next thing is going to be, do we have a database which can store a data in RAM itself instead of disk? Of course, now the answer is yes, which is SAP HANA. So SAP HANA is completely in-memory database. So in-memory in the sense a RAM. So whatever the size we are talking about HANA, it's completely in-memory database. So that is the hardware innovation part you have got in HANA, which means you have got the multi-core processing available, you have the parallel partitioning available, as well as you have got your entire data in RAM itself. So it's a completely in-memory database. So this is hardware side. Now what are the advantages that we got at software side? So in the software side, all the databases that we have now are almost all the databases are all a row store structure format, which means whenever you create a table, it stores data in a row store format. Let's draw a diagram, or let's pick a table. Where you have got your sales information. So let's say I have my sales order, I have my customer number, I have my product number, I have my quantity, I have my price. Okay, let's insert few more rows. Okay, so I've got my sales order trip 4 ones, 3 ones 2, 3 ones 3, 3 ones 4, and my customer number is C1, C2, C3, then C2. Product number is P1, P2, P2, P3. I've sold quantity 100 here, quantity 80, quantity 70, and then quantity 30. Then price is 3,500, and then 2.5k, 1,700k, 1,250k. So let's say this is my sales table that I have in the database. So when we are talking about a row store structure format, at the database level, this entire row will be stored as one record. Okay, so when we look at like how it is going to store in the database level, at the database level, this is how it stores. So the first record, and then the next record, let me format this so that you will understand this format properly. Okay, and then you get fourth row. Then the final row. So this is how it will be stored at the database level. Maybe you have to change the size of this page, or let me change the margins so that it fits properly. So this is how it stores at the database level. So each record will be stored as one tuple. So this is called a tuple. Let me give different color to each tuple. It's a wrong one. Okay, so now, so this is the existing databases storage format. So with this, what happens is every tuple, so it's a tuple, tuple. So each row is called a tuple at the database level. Now with this, what happens is every record has become unique here. So you cannot make out any duplicate record with this kind of storage, because your entire row is going to be a unique at the table level. Now with HANA into picture, you have got a different storage format, which is columnar storage. What is the difference between these two types of storages, and what are the advantages that you are going to get with columnar storage? So how the columnar storage stores data at a database level is, it doesn't store data like this, but it stores data like this. So now in columnar storage, the tuple means this. So this one will become a tuple. Now we have to, okay, so this one will become a tuple now. Let me auto fit to contents. And then you have got the next tuple, which is customers. Okay, and then the product. And then the quantity. And then the price. So in this, so this is one tuple, and this is the next one, and the third one, the fourth, and the fifth. Okay, if you look at these tuples, definitely you have got duplicate values here. You see, C2 has been, has come 2 times in this, and then in this P2 has come 2 times. So what happens with the columnar storage is, as it is going to store all the column values in one tuple, it only stores unique values. It doesn't store duplicate values. So it only stores unique values, which means instead of 4 values, you will get only 2 values, 3 values here. So you are able to save one cell database size. Even here also same thing. So now here we are talking about how many? 4 into 5, 20 cells. In a real-time scenario where you are going to have a sales table with 50 million, 60 million records and some 60, 70 columns. Think about the storage save, the database storage save that you are going to do with columnar storage format. The simple example is going to be, let's talk about a table, sales table with 50 million rows. Definitely, if you're talking about 10-year sales data, easily you are going to get 50 million records in any organization, which means you are going to have 50 million records in one table. And practically how many materials or how many unique products that any organization will have? Maybe 10k different products. So over these 50 million records, you are going to have 10k products. So all these 10k products has been sold 50 million times. So in the product column, you are going to have 10k values repeatedly stored 50 million times. So when we are talking about columnar storage, you are going to save all that storage. It just stores that unique 10k values and it maintains internal indexes like each product belongs to this many rows and this product belongs to this many rows. Same way, think about your customers. How many? 50k customers, 50k unique customers. Same, 50k unique customers stored 50 million times. Think about the states or think about the product group. So obviously your 10k products might have grouped under 500 different product groups. So you're going to store all that 500 product groups 50 million times. So this is called data compression or compression. With columnar storage, you are going to get a very good compression ratio when you move your data from traditional database to HANA. So this compression can be 4 times to 20 times or 30 times, depends on the kind of data you have. Because whether you are using row storage or columnar storage, your sales order is always going to be unique. So you won't get any compression with the sales order numbers because all the values you have is unique. So it always depends on what kind of data you have in your system. So that's where I said it can vary from 4 times to 20 times, which means if you have a database size of 4 TB, when you move to HANA, you are sure that it will become 1 TB. Or with the kind of data you have, it can even become 256 GB system. So you are able to reduce your system size and you have your entire data set in RAM. You are no more storing your data in disk database. You are storing your data in RAM. So the simple facts we have is reading data from RAM or reading data from memory is 100k times faster than reading data from disk, which means your analytics are going to be a lot more faster. You are going to have super lightning speed when you run queries on the data that is residing in HANA. So now you are able to run queries faster, your database size has reduced, and obviously maintenance will become easier. when you have models that can fetch you data in very less time, you no need to store data multiple times like we did here, where you load the data as is into one schema and then apply the transformations and then again move data to a different schema where you apply business logic. So you can do everything in one shot, which means when you want to do any changes in the future, you just need to make changes to one modeling object, which will give you those changes you made in real quick time. So you have got that flexibility also with HANA. And with HANA, you can also do a real-time analytics because HANA supports for a real-time data feed. So you can bring data in real time into HANA. So when you build models on those tables which are getting data in real time to HANA, obviously your customers are going to have a real-time analytics available. Let's go back here. So we discussed about the software innovations we have got, which means you have got both row structure and column structure available in HANA. Because of column structure, you are going to get a lot of compression when you move data from your traditional to HANA. And then with all the multi-core CPU technology that we have got in HANA, you are going to get a lot of partitioning available. And then when you have your database which can fetch you the data sets that you need in seconds, you don't need to do any aggregations. You can do reports on your detailed level data sets. Okay, so these are the differences, these exact difference that I explained to you now. So these our traditional database and this is HANA. So in our traditional database, you have got everything in your database. So these are your database objects and you have got your application or you have got your RAM here. So if you want to do any operations, you have to bring in data from here to here and then do the operations here, then again push the data back to database. So this is a major bottleneck where you have to do, where you are going to have a lot of data movement between your database layer and your CPU or RAM. Now when you move to HANA, you have everything in CPU itself. You have everything in your memory, which means there is no data movement happening in your HANA database. Only the disks we have used here are going to be just to take backup of your system. Because when we talk about HANA and we are saying it's a memory, what happens if you have a power failure or system shutdown, which means whatever you have in RAM will get vanished because it's a volatile, it's not non-volatile. So when we are talking about a volatile system, you need to have a backup where if something goes wrong, you should quickly able to pick up from that source again, put it in your HANA, because you cannot every time whenever the system goes off or whenever the power goes off, you cannot go back to source to load the data again. You need to have a data backup from where you can quickly copy data into your main memory. We'll talk about these topics in architecture session, where I'll explain about what are all the different components we have in HANA database and how those components functions in database. Let's move on to next slide, which gives you what is HANA. So HANA stands for High Performance Analytical Appliance. It's a why we call this as an appliance is it's not just your hardware, it's a combination of both hardware and software. So that's where we called it as appliance. So it's an in-memory columnar oriented real-time supported appliance developed and marketed by SAP in collaboration with hardware partners. So it's like, as I said, it's completely memory, in-memory a database and with columnar structure available, and it also supports for real-time analytics. And the entire software innovation has been brought up by SAP, and the hardware, you have different partners available for to buy HANA hardware, like you have Dell, you have Cisco, you have Intel, you have Fujitsu, you have Hitachi. So there are a lot of hardware partners from where you can buy HANA hardware, and HANA software license you are going to buy from SAP. Now let's talk about the evaluation of HANA, like when the HANA is coming to market and what is current situation of HANA. So the HANA was released into market in June 18, 2011. So that was first HANA version that has been released into market. And till now we have seen 9 service packs for HANA. So SP stands for service pack. So we have got service pack 2 and 3 in 2011, 4.5 in 2012, 6.7 in 2013. The latest service pack, which has been released just 1 month back, is in end of November 2014. So right now we are in SP HANA 1.0 SP9 service pack SP9. So this is the latest HANA version we have. So let's summarize what we have discussed in this session. I have explained about what are the challenges that we have with the existing landscapes at customer locations, and what are the major challenges that customers are facing, and what are the consequences because of that challenges. And then we have seen how HANA can overcome those challenges, and how the latest hardware as well as software innovation has been utilized to build HANA database or HANA appliance, and what is a major difference between your row storage structure and columnar storage structure, and how the HANA is different from traditional databases, and the evaluation of HANA, like when HANA was released and what is the current version of HANA appliance. So in the next session, I'll explain about the rapid deployment solutions, which is another software component that can be installed in HANA, and what are the different deployment options you have available for SAP HANA. Thank you for watching. Have a good day and happy learning.